Thank you. I learned this morning when Bernd showed up that I have to do a second talk. So I prepared one. No, I'm reusing one that I already did at Puppetize Live. So everybody who saw Puppetize Live Amsterdam, the last video, might see some similarities. Same content, okay. One disclaimer first. I'm overstressing things dramatically. For sure, I will do in this talk, definitely, because I wanted you, as long as you just keep 50% of what I'm saying in mind, then I'm totally happy, and then I'm really confident that you will also have success with containers. So the whole thing, the whole story is based on several customer engagements. So that is the reason why I throw everything together, which makes it, being, super annoying and super stressful and super emphasized and, So, for example, this is the thing, ops hates containers. Why is the question? Why do ops people hate containers? So at least we have customers who has ops people that hate containers. And one of the customers, we've been there, and one day one of the ops people showed up and was asking, Martin, we have an invitation from Dev. Dev wants to talk about something they are planning in the production system. I said, hey, that's cool. That is what we call DevOps. It's great. So you start talking about things prior things are done. Yeah, but they want to have containers. And so, hey, that's cool. What's the problem? So you're just dealing with network, with scaling, you don't have to deal with application staging. You don't have to deal with rollout. Everything is done by developers. Yeah, they're quite unsure how this is meant, but can you please join in? I asked them, okay, who else is invited? Yeah, it was dev, developers, ops, the operation parts. They asked me to join and said, please bring in security. So when we started the meeting, the developers were a little bit annoyed that there were more people in the room than they expected up front. And they said, oh, Martin, please don't say anything. We have prepared everything so carefully, and we took care on the ops people so that we don't somehow jump into other people's areas and making distortions somewhere. So I said, okay, we're just here for listening and understanding and maybe helping afterwards. Okay, so then the ops that people started saying, okay, we have responsibilities and we want to have now containers. So they have responsibilities on physical hardware, virtual machines, and they want to expand this concept to containers. Saying, so ops delivers the base OS image for the virtual machines, take care. So ops is now responsible for delivering the base container. And ops is running the virtual machine, so ops is running the container. Ops stages the application, so ops stages the container. And ops ensures together with security on the platform, on the virtual machine, so they do the same on containers. Funny, okay. We were quite shocked when we heard all of this, and luckily the person from security jumped inside and was saying it's not ops that can provide security, check security for containers. A container should only have inside what is needed for the application, not a full-blown OS with several tools around, just the basic application, nothing else. So ops can't dig into the container, so ops can't ensure security. So it must be done by the developers, upfront by doing the development. And by the way, dear developers, please provide additional information on kernel capabilities and C groups limitations that must done on containers. And one of the developers was somehow saying, what's that C groups thingy? We have never heard. What's kernel cap? How do you call that? The answer from security you see on the slides has been adopted to follow a code of conduct. The wording was much more harsh. It compared people with animals and stuff like that. So real hard saying that went on there. That was the point where security stopped the whole conversation and they said, we will not give approval for any kind of container in production infrastructure, full stop. We'll meet again when you have a new concept how things are done. And by that time, I somehow recognized when you walk around the areas, there was a noise missing in the background. There was some noise always there, and somehow it was gone. What's different now? But then the noise came back again, and you heard all the developers saying, Docker, 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 Docker. Docker. So they were all about Docker. So they talk about containers, but they use the term Docker. That's okay. Totally fine with that. It's the packaging format, yeah, for sure. So we want to jump now into why do ops people are so afraid or fear or hate containers. So they really have empathy, but the negative side of empathy. And I always wondered why it is that way. So there are some myths around containers. For example, you never ever need configuration management anymore. It's not needed because you just have everything inside the container. It's pre-configured. You just run the container and everything is fine. It's so easy to deploy and run it. You see, I have it on my laptop. How do we get that laptop in the data center? I have no idea yet, but we'll see. It's easier to test and verify. It's easier to fix issues. It's simple to spin up. It's working from anywhere. I don't need something like status health checks. It's a self-healing platform. It recognizes that something is wrong and reverts to the old version. Some kind of artificial intelligence, I suppose. And don't need to have to do security. It's built in. You see, the Docker documentation says it. Have you seen the sales slides from Docker? They mention security built in. So you don't have to deal with security. When you don't have to deal with security, then why do you need to log in? That's really an anti-pattern at all, but why do you need still logs? Usually you need logs for finding why is something went wrong, but when nothing goes wrong, you don't need logs, you don't need monitoring. You don't need some kind of hardware for it because it's the cloud native thingy. Yeah, so you take the container and does someone has the Siemens Lufthaken? Siemens air hook, so we just hook it there and it's running there. Seems to be something different. And there's a couple of more things that people usually say that's weird things they talk about containers. The first thing that people must learn is a container is not a virtual machine, full stop. It's not is the important word. It's not a virtual machine. It's not a full operating system. It's just the application stack, full stop, nothing else. Docker is the packaging format for containers that made it simple for people to write shell scripts to create containers. And within these scripts, they build layers. So they have some base layers, a base image, let's say it this way. And upon this base image, they provide layer on layer. They install the software they need for running it. They add the application on top. And this is what we call layers in this stuff. And please, container needs infrastructure. And when it's laptops, then the laptops are the infrastructure. Otherwise, you have other hardware. It's not laptops, it's mostly servers. Whether the servers are your own servers or whether they are rented servers, that's completely different, but it needs some infrastructure. And a friend of mine always says containers are like binaries. You just get something. You can't look inside. Maybe you have command switches that change the behavior of the application inside the container, for example, enabling debugging, disabling debugging, providing information for a database backend and stuff like that. It's a binary. For binaries, I suppose we have a solution around, so having them in multiple places, installed, configured, and running. I heard people doing configuration management for providing and installing binaries somewhere. So, why do everybody is talking about Docker when it comes to containers? Because Docker made it possible for people to easily create a container. Who has ever dealt with BSD? Oh, only a few people. The BSD people will laugh about this Docker hipster thingy stuff because they say, we have this since ages, it's called jails. It's a change root. I don't know, when did BSD introduce jails? I suppose in the late 80s maybe? So it's maybe 90s, okay. But it's there since 20 years. And now something in the Linux kernel took place. And what Docker did was take functionality which is already inside the kernel and just provide a packaging format. And now you can just run a Docker pull, Docker run, and everything's fine. And you can curl -k pipe sudo bash. And this is the way how we install software nowadays. Who is running a production infrastructure with internet access? What is it in my first talk? We had it unprotected sex with the internet. I still forgot about the name of the person who was saying it. So it's the same pattern. You just download somewhere an image and you just run it in your infrastructure, and then you're happy. Okay, I don't feel happy with that. Another thing which is problematic for ops people, why they are so empathic towards this container thing, is that they say, what is it that we now have to learn? So we learned Puppet. No, we didn't learn Puppet. What did we do first? We had to learn Git first. Then we were able to learn Puppet afterwards. Okay, so what is it that we have now? Oh, now we must talk about container runtime engine, container orchestration. How is the network working inside containers? Do we still have something like VLANs on switches? Do we still have switches at all? Well, welcome to the modern world and SDN, software-defined networking. It's a fast-changing environment, so definitely would not like to have that connected to physical hardware. Maybe, so the infrastructure, yes, but not what is communication inside containers. So they see something where they say it's huge, it's gigantic, and we don't understand the whole picture. And then it's the thing where you say, draw it into single slices that are easy to understand. So it's like how to eat an elephant. You don't do one bite, it hurts a little bit. You try to slice it into little pieces that are easy to understand, and maybe share responsibility. One is responsible for that piece, another one is responsible for that piece. You have to cut it down into simple to understand problems. Another approach, while people are so now, well, the container things, it's hard, and it's the historic. It's history. On the lower line, on the X line, I have the timeline. On the left-hand side from your side, so here, we have something like the past with mainframes, and on the right-hand side, we have something like present, future, near present future with containers. So mainframes, we only had, well, 1, 2, how many mainframes did you have around? They were super expensive, they were super large, somewhere in the basement. Then we shifted from mainframes to personal computers, 400 accounts with terminal servers on the mainframe, now have 400 PCs next to them. Then people were thinking about better usage of the hardware, on the physical hardware, by saying, oh, well, why not stack everything inside, make it movable, make it, no, not containers, virtual machines. So we had plenty of virtual machines. At one customer, the first environment for the developers was 25 servers. On these 25 servers, we now have 1,500 VMs running on top. So consider the vertical scale to be logarithmic and not linear. And now it comes to containers. And we see it at the same customer. We've introduced Dockerd in the CI platform, and we asked security first, are we allowed to use Dockerd in the CI platform? They mentioned yes, but not downloading images from hub. You have to have a local registry, and then it's okay. And these systems are not allowed to access internet and fetch images from the internet. A couple of months later, we had a look into our internal registry because it was behaving something different now, and we saw, wow, what's that? There's 300 gigabytes of containers inside. So developers learned that there is now Dockerd in CI and that there is a registry, and they now create containers. The weirdest one we've ever seen. Every commit generates a 3.5 gigabyte size container, and on every CI they pull the new 3.5 gigabytes over the net. Okay, so expect even larger numbers of containers when you enable developers to make use of containers. So that's not really the problem, just more systems. Okay, we can just deal with it, more systems, more hardware. It's a standard pattern which we already had in ages. On the other hand, let's have a look on availability of systems. So a mainframe is usually, say, running per se. As long as you don't cut off the power, the thing is just running. With PCs, it's already a little bit lower. There was an advertisement movie on YouTube where you had a Hamburg-based company moving their office from one location to the other. And one gateway, the BSD gateway, I suppose, they placed it onto a card, a UPS next to it, power supply, and a GSM dongle, so the monitoring can still say, I'm pinging that thing. And they moved that in public transportation. It was a marketing video saying, hey, we're a smart, cool company, come join us and work for us. Then they said, this is a supercritical heavy system. It has an uptime of, I have no idea, 500, 600, 700 days. Oh, Have you asked security about updates? 500, 600, 700 days? How many kernel upgrades did you install? Maybe consider rebooting. So it's now no longer a mainframe. You have to reboot physical hardware, so less uptime. Virtual machines. Yeah, virtual machines are running always. Yeah, and even when you migrate them, and usually they don't live that long, maybe they only don't live for years, maybe only for months, so let's say lower downtime, lower uptime. Now it comes to containers, and there's the thing, how long should containers run? Who of you is already using containers out of pure interest? Just a couple of people. What is the longest running container? Who has a container running for more than 1 month? Nobody. Okay. 1. Okay. 2. A couple. 3. Okay. Who's running containers for less than 30 minutes? On every CI run. We spin up a container and we destroy it afterwards. And this is the real concept behind containers, short-living instances. And there is something more in the future that will come, which is not on the slides here, where you have something that will spin up per request, answer the request, and will be tiered down again. At Amazon, they call this Lambda, for example, function as a service. Okay, so yeah, now we have more systems, less uptime. Who's looking for people? Where's the company hiring? Usually I would like to expect everybody to raise his hands because everybody is looking for people and hiring. The problem is that the staff does not scale with the numbers of servers. So in the past you had a couple of people taking care on a mainframe. Then these people, okay, now you did the mainframe, now you can do the personal computers too, that's okay. Now you have on these physical hardware, you now have VMs running, that's also okay. And on the same hardware, you're now running containers. Maybe we can even reduce because we're going to the cloud. Hey, that's great. So we need less people because we have less hardware. So that's the problem. And there's only one way how you can deal with that. And that means go for 100% automation. Stop doing something when you work with containers in a manual way. It's not possible. When you see correct usage of Dockers or containers, you have something like a platform that has a constant defibrillator somehow connected to this. Things are up, things are moving, things are down again, and it's even hard to monitor. And when you have to do something manual in that pattern, well, yes, I know. I still hear one of my former colleagues saying, Martin, this is not the way how projects work. You can't go for 100% automation because are you aware of the 80-20 pattern? Who knows from projects the 80-20 pattern? Everybody knows it, yeah. Yes, 100% of the things that you need to do and 80% of that is something you make into 20% of the time. So just do the 80%, that's okay. Everything else is too much work to do. This pattern still exists now also with containers or even everywhere. It just means that you're spending 80% of your time doing the 20% not automated. So automate everything, yes, that's a valid approach now. So, but where do we start now? So how do we now deal with containers? We have these things now, developer deliver it somewhere, and we have to take care about. The first thing I recommend is hands off the keyboard. Start reading. Don't just do something because you found a blog posting from 2015 explaining you how to do the stuff with containers. Check for blog postings on the date when they were written or have they been modified afterwards. So start reading first and then start implementing things. There's some nice reading, for example, 12-factor. There are now some extensions to it. It's up to 13 or 15, depending on who you're asking, that describes even some developer concepts on what is a container, how you should deal with it, how should it be prepared, what should be inside. Consider it a short-living instance, and please take care when you stop a container, every change you did in the container is gone. So don't store anything in a container because it's not persistent. It's volatile data, but you definitely want to have some persistent data, like customer information in a database, rendered images on a storage system, something like that. Now it comes to building your container infrastructure. The first thing we did at a customer, they gave the ops people, say, hey, have a look, please install OpenShift on the production servers and check that developers can work with it. We don't know how this thing is working and how it is meant to be used. We then made the decision for saying, hey, we're introducing first containers into CI/CD so people can learn and make errors on the CI/CD platform with containers by just installing Docker, full stop. And we did this with the Puppet Labs Docker module by specifying this is the network that we want to use, this is the storage backend, the file system backend that we want to use. So that's the thing. On enterprise customers, they can even use Puppet Discovery to see what kind of systems do I have now running inside this Docker daemon. So even if you just say Puppet is only there for installing, configuring the Docker D and ensures that it is running full stop, everything else is out of scope of Puppet when it comes to the container world. But you want to see maybe afterwards, what is it that I'm having running on my Docker D? Like I mentioned, ops people, please think about ideas on where you might be able to use containers for ops, let's call it this way. The first thing, rarely people do this, I learned already, but we are unit and acceptance testing our Puppet code. So that means for acceptance testing, we spin up a container for each of the operating system that we must support. We copy the Puppet code inside, we apply the code, and afterwards we check with server spec that the container is working as expected as a normal system, and regardless of the result, we destroy the container afterwards. So it's gone again. Another solution is build processes. So in the CI system, we now offer containers for developers as build containers. So they don't do this on the standard CI system anymore. The nice thing is when they want to have a change on the container, it's distributed everywhere and not only on that specific CI server. And it's always in the same state when they start. So it's not like there are some artifacts left from a former run. We use containers for dashboards. Usually teams change dashboards upon every sprint. We have some long-running dashboards. Yes, we also have a container running for a month. That are some dashboards we have around. But usually they don't run that long. Usually they somehow die out of memory due to C group settings. There's another thing directly from Puppet. It's called Puppaware. Welcome to the Puppet server as container, starting with Puppet 6. So you want to spin up a Puppet infrastructure for testing, whether your code is ready to run on Puppet 6, or what is it that we have to do? We need to create a VM, we need to bootstrap this to a Puppet master, so ideally via Puppet, but we don't have a master yet, so it's like Münchhausen in the desert, pulling himself out of the sand. We do something similar, yeah, we have a script around for doing so, that we spin up a Puppet server. Now you have a container. Just spin up the container and check that your code is working. Okay, now we have the single host. There was the Docker D. Now maybe that single host is no longer, well, what is when the host is down? What is when the application needs to scale a little bit? Then you need to think about container orchestration. Yeah, Kubernetes. It's always the first term you hear around. It's container orchestration. So you want to be sure, for example, saying, I need 5 of these instances, or at least 4 different container runtime engines. I want to have room for scaling. So you want to have multi-node container runtime, and now you have multiple nodes with a container runtime, and now you want to orchestrate rollouts on these multiple servers. Everyone has a container runtime locally. They don't know about each other. It's not meant that way. You want to take care on maybe someone needs to access your infrastructure. We're just a shop portal. Nobody needs to access a shop portal. That's totally fine. Then we're super secure because we are in offline mode. Nobody can attack us. No, you want to take care on ingress, inbound traffic, and egress, outbound traffic. Consider maintenance. So maybe you want to somehow switch off some piece of hardware when you're running on-premise, or you want to maybe reduce the number of virtual machines you're running on your cloud provider. What will happen with the containers that run on these? Of course, they will be destroyed and gone, and the container orchestration will take care that you spin up again new systems depending on how much did you first destroy by tearing down that physical hardware with a hardware failure, for example. Yeah, but how do we now install Kubernetes on a system or something different? Well, there are modules around for Kubernetes. Tim already mentioned lots of pull requests because things are not as they should be. Yeah, that's okay. There's a Docker Universal Control Plane. What is Universal Control? Welcome Docker Enterprise Systems. And there's the Docker Data Center, which is the control plane plus a trusted registry. By the way, when you start with containers, take care on a trusted registry right from day one. We need not do it at a customer. And what is it now? The people were unaware about namespaces. They were not signing their images. So you can just download an image, tag it, and just upload it to the registry. There's no authentication, no authorization upfront, so that identifies who are you and is this really your image. You can just curl somehow a Bitcoin miner and just upload it as CentOS 7 base image locally. And yeah, you just have to provide the credentials on which wallet should get the Bitcoins afterwards. So take care on a trusted registry right from day one. Another thing that people think about is, should I run this locally in my own data center, or should I place it somewhere in this cloudy thingy? So Docker, you always hear containers and cloud native, that always runs in parallel, that they say, yeah, container is the implementation for being cloud native. So no vendor lock-in to a specific cloud provider. And of course, we're using Kubernetes because it's from Google. So full stop. And when it's good enough for Google, then it's good enough for me with my one Java application that I have around. Don't directly start with Kubernetes. Think about your use case. There's other things around. Maybe there's Rocket or CoreOS. Maybe even Nomad and Terraform is already helpful for you. Maybe Docker Swarm is already sufficient to just build a small-scale cluster. You can't scale big in these things, but when you don't need to be big, why should you really directly deal with Kubernetes? That's because everybody is doing it, and it's so easy. You just write YAML files. Doing the indentation right is the competition you have to deal with. Okay, so everything in container. We place a DB2 in a container. We place an Oracle database inside a container. You're making Oracle happy. How many? You want to run Oracle in the container? Okay. How many cores does your whole cluster have? 5,128. Welcome. We are paying to Oracle for all cores inside. No, there's still stuff around where you say it makes no sense containerizing this stuff. Your persistent data, for example. Maybe you don't want to have them in a container or in a volume. Or there are some things like enterprise-y applications that are somehow saying, no, you may not run in a container. You have to run on a specific operating system version. Yeah, which one is it that I have to use? /10, please. It's outdated? Yeah, but it's only supported on /10 for us, so okay. And not run it in a container, it must run on physical hardware. Oh my God, okay. So there is still purpose for Puppet, but it's more for the infrastructure part. It's not what you have running inside of containers. There, Puppet makes no sense and is definitely obsolete. But the underneath that you build an infrastructure for people to use, this is where Puppet comes in place. And stays in place, or will come in place. Monitoring. Isinga still has the API? Okay, so it's nice. So container can register themselves and deregister maybe. Because you need to consider your monitoring being different. You have something like a platform that is constantly moving around. At 8 o'clock in the morning, you have 10 front-end servers, 10 front-end containers running on your 10 Kubernetes swarm nodes, whatever you call them. Then you have an announcement that the king of rock and roll will give a concert and you're the concert provider, and by noon you have 5,000 instances running for a couple of hours. Then the tickets are all sold, or the people learn the person is no longer giving concerts, and then you tear them down again. So usually we are known to, well, let's use exported resources in Puppet, and then they get collected on the monitoring server, and when they are collected on the monitoring server, the container is already gone again. So use something which is more built for flexible platforms, and not something like an outdated old monitoring solution. Yeah, like I mentioned, Isinga with the API call. At one customer, we showed them Isinga, Sensu, and Prometheus, and he said, I like Prometheus because I get data, and I can visualize it, and I can do alerting. So we don't longer do monitoring, we just do data, metrics, and alerting. That's it, what people now do in this case. You're more interested in the global health, that you say, the service must run and be available, and I want to have at least 5 systems. When there are 25, then everything's fine, then we have 25. As long as the 25 service is still running, then everything's okay. The other part is the hardware part, where we say, yeah, okay, we have, our manager has been to, our CEO has been to a technical advisory function somewhere. And he came back and said, oh, we're doing so much wrong nowadays. We still own servers. We should go serverless. Okay. Okay, so no more service. The Siemens Airhook. Here we have it. And by the way, we're doing everything wrong. We have far too many people. We can go opsless. So no longer ops needed. Okay, so serverless, opsless, useless, brainless, painless. There are plenty of words you can do with less, so for sure. Well, serverless does not mean no hardware. It just means you don't own it. You have rented it for a certain period of time from a cloud vendor. Opsless does not mean that you don't need ops at all. It just means that the cloud vendor gives you a tool chain that does on a per button basis your ops work that you're doing. Yeah, so is that now the real approach? So I already learned it in Germany, the best company with the most profit is the company with no employees, because employees always cost money. So don't know why companies still hire people, because they would make more money when they don't have people. Yeah, but now you have no people and you're moving to the cloud. Is this really the best cost-efficient way for you to manage your infrastructure? We don't know. Ask finance. Finance will tell you something about capital expenses and operational expenses. And I say, we would like to have capital expenses. It's better from the tax perspective compared to having operational expenses. So somewhere you will reach a point where you grow in your cloud infrastructure, where the cloud infrastructure becomes much more expensive than running your own data center. Please consider this. I know people saying we do DevOps, DevSecOps, now we do DevSecFinOps. Yeah, we also collaborate with finance in this part. Okay, a slight summary. Let's say it this way, someone opened Pandora's box. Yes, it's Pandora's box, because what the box left cannot be placed back inside. So that's the reason why it's Pandora's box. So someone opened Pandora's box, and out of the box, we pulled a container. So the container is now larger, you can't place it back into the box. So that's okay, we have now containers. The container adoption increases. We even see this at enterprise customers asking us, okay, how does Puppet and container correlate? How does this work together? We want to bring the application near to the customer. So it's coming anyway. So stop complaining, start dealing with the stuff, start learning the stuff, start doing containers. When you build something, on-premise, off-premise, regardless where you do it, when you build something, security first and full automation. If you skip one of these, you not have a proof of concept, you just have a pile of crap. You must be able to rebuild it instantly with a button. Then you're sure you have built a proof of concept. You can tear it down and spin it up again. Like I mentioned, automate everything. Choose your tooling you'd like to have. Maybe it's not Kubernetes, maybe it's a smaller solution for you, maybe you still have to learn. And then the thing is, where I say, it's not that Ops hates containers, Ops hates systems they are unaware about and they don't have under their control. Thank you.